Factoring by splitting the linear term. So this is a relatively powerful technique. Um, before we do that, let's agree on how to factor by greatest common factor. These are both divisible by 4x, so we can divide them by 4x and we'll be left with x cubed minus 10. If you've forgotten how to factor by greatest common factor, do that. So the idea is that when we multiply polynomials, we can say that this is x times x gives us x squared, x times b gives us bx, a times x gives us ax, and a times b gives us ab. If you look at these as like terms, then you can say x squared plus a plus b times x plus ab is the same thing. So you'll see that there are two numbers here that multiply to give the final term and add to give the linear term. So what we're going to try to do is we're going to try to go from here to here in order to get all the way back to the beginning. So this is about splitting the linear term, to finding that there are two things that add up to give us this, bringing us back to the original. So here, what I'm going to look at is 18. I'm going to look at 18. I'm going to look at the possible factors of 18. So 1 times 18, or 2 times 9, or 3 times 6. Those all add up, all multiply to 18. So we're looking for something that adds to 11 and positive 2, positive 9, multiply to positive 18, and add to 11. So what we'll do is we'll use that to split our linear term. 2x plus 9x plus 18. Now we can factor each of these by GCF. So x times x plus 2. This is 9 times x plus 2. Again, we've divided each of these by 9. We've divided each of these by x. And what we're left with is x plus 2 is the greatest common factor here. So we divide by x plus 2. Divide by x plus 2. And what's left over is x plus 9. So that is our factored form of this. So let's do the same thing with now some negatives thrown in there. Negative 7 can only be made from 1 and 7. In order to get negative 6 and negative 7, we need to use a negative 7 and a positive 1. So when we split this linear term, we'll say x squared plus x, or 1x, minus 7x minus 7. Now we factor by greatest common factor. Here the greatest common factor was x. So when we divide by x, we divide by negative 7. We will get x plus 1. And dividing these, we'll get x plus 1. Leaving us with x plus 1 times x minus 7. Here, the number that we're splitting is negative 7 again. So we have 1 and 7. In order to get to positive 8, we need a positive 1 and a positive 7. That doesn't work. So this is what we consider unfactorable. Or another word we could say is this is a prime factor. We cannot factor this any further, and that's going to happen sometimes. So let's try it with the second one. If we have negative 90, the numbers that multiply to negative 90 are 1 and 90, 2 and 45. You can skip over them if you know which is actually going to work. 330, 4 doesn't work. 5 times 18, 6 times 15, 7, 8, 9 times 10. So in order to get positive 1, we need a negative 9 and a positive 10. We'll multiply to negative 90 and add to positive 1. So we have m squared minus 9m plus 10m minus 90. Now we factor by greatest common factor. These are both divisible by m. These are both divisible by 10. So when we divide, we get m minus 9 and m minus 9, leaving us with m minus 9 times m plus 10. Things that multiply to 40. So 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, 6 doesn't work, 7 doesn't work. Okay, so we're good. Now, we're looking for things that will give us negative 13. So negative 13, we can use negative 5 and negative 8. Will they multiply to positive 40? Yes. So negative 5, negative 8, k squared minus 5k minus 8k plus 40. Now, here, we're doing greatest common factor. K is what we're dividing by there. Negative 8 is what we're dividing by there, leaving us with k minus 5 and k minus 5. Now you might start to be noticing the pattern where usually for all the things that we've done so far, it's ended up being those two numbers end up being the same that are going to be in the parentheses. I'm doing it this way, the long way, because later when we do harder problems where this number, where there's a number before v squared, you want to be consistent. So now you could go through the whole list of things that multiply to 100, but I think from 99 you can figure out it's going to be 1 and 100. So in order to get to negative 100, or sorry, positive 99, we need positive 100 and negative 1. So this will look like v squared minus 1v plus 100v minus 100. Greatest common factor there is v. Greatest common factor there is 100. So now we get v minus 1 and v minus 1, leaving us with v minus 1 times v plus 100. Here, these numbers got bigger, but you can always check for a greatest common factor first. And here, 5y cubed, sorry, 5y is part of each of these. So we can divide by 5y, get, divided by 5y gives us 110 divided by 5 is 22y. And then that gives us 72. So now we can ignore the 5y. It'll still be in our answer, but for this internal polynomial, we're just looking at 72. So 1 and 72, 2 and 36, 3 and 24, I believe. Yeah, 4 and 18. Okay, that'll work. 4 and 18 if we use, does that work? Yeah, negative 4 and negative 18 will multiply to positive 72 and add to negative 22. So 5y, y squared, minus 4y, minus 18y, plus 72. Now we're factoring by GCF. 5y, y times y minus 4, minus 18y minus 4. So what we're left with is 5y times y minus 4 times y minus 18. Here, they're all divisible by 9xy. So 9xy. We're left with x squared plus x minus 12. Things that multiply to negative 12. 1 and 12, 2 and 6, 3 and 4. We need a negative 3 and a positive 4. I'm going to shortcut this and say this is 9xy times x minus 3, x plus 4. You could split this into negative 3x and positive 4x, and it'll eventually get here. Same thing here with 2 times t squared minus 14t plus 49. The numbers that multiply to 49 are 1 and 49, or 7 and 7. In this case, it'll be negative 7 and negative 7 to get positive 49 and negative 14. So 2, t squared minus 7t minus 7t plus 49 is 2, t times t minus 7 minus 7t minus 7. And now we have t minus 7 times itself. I would accept this, or even better would be you'd see 2 times t minus 7 squared. Last one, here they're all divided by 6, leaving us with x squared plus 2x minus 80. 80 can be done 1 and 80, 2 and 40, 3 doesn't work, 4 and 20, 5 and 16, 7, 8, and 10. So positive 8? No, negative 8 and positive 10 will work. So 6 times x minus 8, x plus 10. That's how we factor by splitting the linear term. Thank you.